Hi, my name is Jeanette, and I'll be going over how to find a domain of a function. First, I will be going over some basic vocabulary. A function is a mathematical process that uniquely relates the value of one variable to the value of one other value. Or, we can just say, a function takes an input and produces one possible output. This right here is a function machine. You put in one input into the function and you get one unique output. For example, you have an input of x equals 3 and a function of x squared. You put in your input, which will be 3, into the function, which will then be 3 squared, and you'll get an output of 9. This also means that you do not have a function when you have one x value that goes to multiple y values. If you look at the x value of 5 here, you can see that it does not have one unique y value. 5 goes onto 4, 5, and 7 of the y values. Another important term to go over is domain. Domain are all possible x values. When asking for the domain of a function, it is the same thing as asking, what are all possible x values for the function? Now that we have reviewed domain a function, we can go on to some examples. Example number 1. State the domain of the following relation. Is the relation a function? Remember that domain is all possible x values, so you will just be looking at these. That tells you that 2, 3, 4, and 6 is your answer. And this is not a function because the x value of 2 has 2 different y values. You can see on here that the x value of 2 goes on to -3 and 3. Example number 2. State the domain of the following relation. Is the relation a function? Once again, you are looking at just all values. All x values, sorry. So you'll be given with the answers of -3, -2, 1, 0, 1, and 2. This is similar like the last problem, but this is a function because each x value has its own unique y value. With these examples, you want to make sure that you know that it doesn't matter that the y values here are all 5. It just matters, what really does matter are your x values. Example number 3 here is now a little bit more visual. The domain here would be all real numbers because the arrows go on to infinity for both sides. You can see on here that x could be all real numbers, or it can go on to -infinity and +infinity. Example number 4 is just a little bit harder. We see that there is a point on the graph at -4 and 2. Remember that open circles mean that it is not included in the answer, and closed circles means that they are included. So, with that we can see that -4 would be included on the graph. We can then conclude that the domain for this graph would be any number greater than -4. Example number 5 is just a little bit more complex than the ones we've gone over. This asks to find the domain of fx equals x minus 2 over x squared minus 4. With these type of problems, you can either plug them into your calculator to actually see the graph, or you can solve for x. To do this by hand, we must set the denominator equal to 0. You then get your x values of -2 and 2. This then tells you that the domain of x minus 2 over x squared minus 4 is -infinity and -2 union, -2 and 2 union, and 2 and positive infinity. And then this is just a visual of the function we just worked with. This is the applet I have chosen to help you more on finding the domain of a function. With these problems, you want to remember that you can either graph them to have a more visual, or you can work them out. By working them out, you're truly really asking yourself what x can't be, because as your denominator, you can't have 0. So for this problem, you know that you can't have -1 as your x, because that will then give you the denominator of 0. Alright, this asks, click on the left endpoint of the domain on its number line. If it is -infinity, click on the left arrow of the domain number line. This right here is the graph of the last function. You can see here that the domain for that function would be -infinity. We're now back on the problem and we press -infinity. Great. Now click on the right endpoint of the domain on its number line. If it is infinity, click on the right arrow of the domain number line. If we go back to the graph, you can see that the endpoint for that would be -1, because after -1, there won't be any more x values. So we'd go right ahead and press on -1. Perfect. Now decide if the endpoint is included or not. With that, you want to remember that your denominator can never be 0. So if you put in -1 for your x, it will be 0. So that means that it does not include the endpoint. Because if you included the endpoint, plugging that in will produce 0 in the denominator, like I said before. So, new problem. Y equals 5x squared plus 5x plus 1. With this type of problem, it'd just be a lot easier if you'd plug it into your calculator. I'm sorry, I'm not quite sure what's going on with this applet. It just honestly keeps on changing the equation. I wanted to show you guys a graph, but it just keeps on changing it for me. But with these type of equations, you really want to know that once you graph it, you'll get a parabola. And with this parabola, you should know that it would go on towards -infinity and positive infinity. Alright, let's go over maybe one more problem. So y equals x minus 2 over the square root of x minus 1. Remember that you want to make sure that your denominator is never equal to 0. So for this problem, for the endpoint, for the left endpoint, it would be one. And for your right endpoint, it would be towards positive infinity. Now let's decide if the endpoint is included or not. If we have 1 as your x, it will be equal to 0. So that means that you cannot include it on the endpoint. That now concludes the end of my presentation. Thank you.